Now let's take a look at our last problem here. Seth invested money into two accounts, one paying 5% interest and the other paying 6% interest. The amount invested at 5% was $1,000 more than the amount invested at 6%. He earned a total of $820 interest in 1 year. Use a system of equations to find the amount invested in each account. So the first thing we're going to do is find our variables, or set up our variables, I should say. Alright, so our first variable is going to be x, and x equals the amount invested in the account paying 5% interest. And then our second variable is going to be y, which equals the amount invested in the account paying 6% interest. Now we're going to set up a table to help us figure out what our equations are. So here's our table, and in our first column we have the amount of principal interest invested at 5% and 6%. At 5% the amount is x, at 6% the amount is y, and our total is just supposed to be the total principal amount invested, which we don't know. And now down here we have interest, and under 5% we're going to have 0.05 x, and this equals the interest earned at 5%. And right here at 6% we're going to have 0.06 y, and this equals the interest earned at 6%. Then under total we're going to have $820, and this equals the total amount of interest earned. Now we're ready to set up our equations. Okay, so for setting up our equations, let's look back at the problem first. In the problem, it says that the amount invested at 5% was $1,000 more than the amount invested at 6%. So that means that x, which is our amount invested in the account paying 5% interest, is going to equal $1,000 plus y. And y is the amount invested in the account paying 6% interest. And for our second equation, we're going to have 0.05x plus 0.06y equals 820. And recall that 0.05x equals the amount of interest earned at 5%, and 0.06y equals the amount of interest earned at 6%. When you add these two together, you get the total amount of interest earned. Alright, and before we go ahead and solve for our variables, I want to get rid of these two decimals right here. To do that, multiply this whole equation times 100, and I get 5x plus 6y equals 82,000. Now we're ready to solve for our variables. So I'm going to use the substitution method for this problem, because in our first equation we have x equals 1,000 plus y, and therefore we can just take this equation right here and plug it into x for our second equation. So take 5 times 1,000 plus y plus 6y equals 82,000. And now we're going to solve for y. right? And so then we get 11y equals 77,000, and then divide 11 both sides to isolate y. We get $7,000, and $7,000 is the amount invested in the account paying 6% interest. Now we're going to take the amount invested in the account paying 6% interest, the $7,000, and plug it back into our first equation. So we're going to have x equals 1,000 plus 7,000. It's going to give us x equals $8,000, and this is the amount invested in the account paying 5% interest. Now that we have both of our variables figured out, we're going to check them by plugging them both back into each equation. So for the first equation, you can see right here that 8,000 equals 1,000 plus 7,000. So we know for sure that the first equation works out. But now let's check for the second equation. Second equation, we have 5 times 8,000 plus 6 times 7,000 equals 82,000. You got 40,000 plus 42,000 equals 82,000. Then we get 82,000 equals 82,000. Right? So both of our variables work, which means that x equals $8,000, and $8,000 is the amount invested in the account paying 5% interest, and y, which is $7,000, is the amount invested in the account paying 6% interest.